Hey there, friends and neighbors. Now I'm going to show you how to do a chi-square test of independence, also called a two-way contingency table test. It's got a bunch of names. Those are the easy ones that we're going to talk about. So, the two-way chi-square table of test of independence with real data homework, we're going to test the hypothesis that there is no relationship between gender and the rating of the Star Wars movies, okay, the most recent Star Wars movie. I'm going to work with two variables, two categorical variables. We're going to work with sex, which is self-reported sex, of which there are four categories. And then Star Wars reduced, which is a simplified version of that 4 stars that you could give a movie. That is boiled down to having 3 categories. And here they are. The row variable should be sex. Okay, now the first thing I want to get is my descriptive statistics, which is the row percentages. So I'm going to go to R. We've already got R Commander Easy R, and we've got the data set imported. Here's how you do it. Statistical analysis, discrete variables, create two-way table and compare two proportions. That's how you do it. Click on it, and the row variable is going to be sex, as stated in the question. The column variable is going to be Star Wars reduced. We have row percentages for our descriptive statistics. I want the chi-square test because that's my inferential statistical procedure. I want the components. In case I reject HO, I need to find out why, and that's what the components are for. Print the expected frequencies. That's how I check my assumptions to decide if this is even a valid test in the first place. I turn off the Fisher's exact because it's not appropriate here. I turn off the continuity correction, also not appropriate here. And then I click OK. Now it drops you off in a bunch of stuff you don't really want to keep, so I'm going to scroll up to the top where it shows me my raw frequencies. There were 0 female people who identify as female who gave it 1 star or 2 stars. There were 7 who gave it 3 or 4, and 23 who have not seen it. So most of the women had not seen it. The 7 women who had thought favorably of the movie. Now in terms of descriptive statistics, the row percentages are here. Of the 30 women who people who identified as women, 0% of them gave it 1 to 2 stars, 23% gave it 3 or 4, and 76.7% had not seen the movie. That's my descriptive stats. So 0, 23.3, 0, 23.3, 76 point, I think it was 0.7. Yeah, and then there are 30. Okay, for people identified as male, 11.8, 29.4, 58.8, and 17. There were 17 people who identified as men. There was one person who identified as neither, and one person who identified as other. That one person who identified as neither gave it 3 or 4 stars, and that's why it's 100% there and 0% everywhere else. So 0, 100, 0, 1. For the other category, it was 100%, 0, 0, 1. Okay, submit, and there you go. That's my descriptive stats. Next, I need my graph, and a graph is not automatically part of this output, so I have to produce it myself. It's not very difficult. You go Graphs and Tables, bar graph for frequencies, choose as your row variable, choose sex. Actually I should choose as the outcome variable Star Wars reduced, and the grouping variable, which would be the equivalent to the row variable, would be sex. I like to draw it in color, and I like to set them side by side, so that's what I'm going to do. And then I click OK, and here it is. Now you can, if you're doing this on a Windows machine or a Mac, you can right-click to save it in any format. I've already done that. It's right here. So right-click, Save As, and I've got a name for it, so that's fine. I'm going to upload that, and I'll be using this to make sense of it all. Okay, submit. That's done. Next thing, I'm going to go to question 8. So I've done my descriptives, I've done my graph. The null hypothesis is that there's no relationship between gender and Star Wars ratings. That is to say, the row variable and the column variable are independent. Rows and columns are independent. The alternative is that there is a relationship. That is, rows and columns are related. I'm going to let alpha be 0.05, and all that stuff is defined for me before the question comes my way. Now I do the assumption check. So the assumption check for the chi-square test of independence is that all expected frequencies are at least 5. That's the assumption. What's the smallest expected frequency? Ooh, now we check this. Go to the R output, scroll till you get to the expected frequencies. So there's chi-square components. There's the expected counts. So it looks like the smallest one, these two are equally small at 0.06. Yeah, that's the smallest, 0.06. Okay, well, is 0.06 at least 5? No, I do not meet the assumptions. Now, in professional data analysis, we would stop or fix this, but this is just a project, so we're going to save it and we're going to move on. Submit. All right, question 9. And I've stored my responses to the assumption check. Well, actually, I haven't stored them. Here they are. Now I do the chi-square. And this I just copied directly out of R. Where is it? It looks like it's that. Looks like it's 21.562. We've got 6 degrees of freedom because there's 4 rows and 3 columns. 4 minus 1 is 3. 3 minus 1 is 2. 3 times 2 equals 6. So 6 degrees of freedom. And then the p-value is here. It's 0.00145. I'm going to cut off the 3 at the end. Decision. Now the p-value is lower than alpha. I'm going to reject HO. And that's that. Next question. Question 10. Builds on that, and now we need to make an interpretation. What do I conclude from this? Well, and it just copies my numbers. They're right, but they're not necessarily going to be right. It's just I copy the numbers that the student gave. So do I reject? I rejected HO. What does that tell me? It tells me either that there's no relationship between gender and rating, or there is a relationship. I rejected HO. HO was no relationship. Therefore, there is a relationship. You can come back up here and see that I rejected this one. Therefore, I believe the other one. Okay? There is a relationship. Now, for the sake of simplicity, if you reject HO in an omnibus test like a chi-square or an ANOVA, you're not done. You need to figure out what the differences are, what caused it to be significant. So I need to look at each cell, and looking specifically at the chi-square components, aka Pearson's residuals. We look for components that are at least 4. Now, to keep this simple, because this is an introductory class, it's a class project, I'm just going to look at the chi-square components that are largest. So here are the chi-square components. What's the biggest one? It's right here at 14.39, which we have for other sex and 1 or 2 stars for the rating of the movie. So that's that. It's 14.39. That is for the other 1 or 2 stars. So either people who identify as other sex hate Star Wars, or they love Star Wars, and I needed to decide which by seeing whether the observed is higher than the expected, or vice versa. Well, looking at the expected counts and the frequency, expected. So expected and observed. So I'm going to scroll up. Actually, expected is right here. We expected 0.06. Copy that. We expected very few. And we observed, let's see how many we observed. Scroll to the top to your frequency table, and we observed other 1 or 2 stars. We observed 1 person. So we observed 1. We expected less than 1. So it means I observed significantly more than expected. What does this tell me? It tells me that people who identify with, other sex, some sex other than male and female, they appear to love the Star Wars movie. Now, it's not valid because we violated the assumptions. The test doesn't mean anything, but it's a good, interesting class project. Anyway, submit, and that is that.